Hi, welcome to OpenLC Solutions. Today we're going through 2014 paper 2 and we're going to go through question 1, which is all about probability. We're told about this garage that has 5 black cars, 9 red cars and 10 silver cars for sale. The first question we're asked is, when a car is selected at random, what's the probability that that car is black? So probability of picking a black car, let's just use B for black. The probability is how many black cars are there? There's 5. Divided by how many cars are there in total? Well, 10 plus 9 plus 5 gives you 24. And don't forget, when you're doing fractions, you need to simplify your answer as much as possible. Fortunately, this is already the simplest version of this fraction, so we don't actually have to do anything else here. The answer is just 5 out of 24. The next part poses the same question, but this time we're wondering, what is the probability that the car is black or red? So probability of black or red. Well, how many cars are either black or red? There are 5 black and 9 red. That makes 14 out of the total of 24. Now this time we actually do have to simplify down our fraction because 14 and 24 both have a common factor. So this ends up being 7 out of 12. Part B changes things a little bit. Rather than just selecting one car, we're now selecting a car and then another car from those that are left. In that situation then we're asked, what is the probability that the first car you pick is silver and then the second car you pick is black? So the probability that you get a silver and then a black. Well, there's 10 cars there that are silver out of 24. Because both of these things have to happen, we're now multiplying these two fractions together. What's the probability that you pick a black car out of those that are remaining? There are 5 black cars left, but there are only 23 cars left in this stock, because remember, we've already picked the first car and we know that it's going to be silver. That ends up being 50 over 552, which we can simplify down to 25 over 276. Part 2 of this question changes things around a little bit. This time we don't necessarily know what order the cars have to be selected. All we know is in the end we have 1 red car and 1 black car. There's actually 2 ways that this can happen. You can get a red car and then a black car, or you could get a black car and then a red car. Both of those will fulfill the criteria in this question. So let's work out each of these. So probability of picking a red car, first of all, is how many red cars are there? There's 9 out of 24. And then we have to pick a black car, so this is a multiplication thing because we're using the word and. There are 5 black cars out of the 23 that are left. The or in between these implies that we have an addition. Then we look at probability of picking a black car. There are 5 out of 24, because this is a totally different scenario. There are now 24 cars in this lot entirely, because we're kind of ignoring now the previous scenario where we already picked the red and then the black. This is a totally new scenario. So we've picked the black car first, and then we pick a red car second, so that's 9 out of 23. And each of those turn out to be 45 out of 552. Which gives us 90 out of 552, which we can simplify down to 15 over 92. Part C is going to increase the difficulty a little bit more. This time we not only have to choose between different colors of car, but they're also introducing that some of these cars have diesel engines and others don't. So the first thing I think we should do is draw up a table of this new situation. So we have the color that we already knew about. There was black, there was red, and there was silver. And there's now also engine. And the option is either diesel or not diesel. let's say not diesel. Now we're told that 3 of the black cars have diesel engines, so you put a 3 there. 2 of the red cars, 4 of the silver cars have diesel engines. Then, because the only other option is not diesel, that means that there are 2 black cars that are not diesel, because remember there are 5 black cars in total, so if 3 of them are diesel, then 2 of them have to not be diesel. With the red cars, 2 of them are diesel, which means that 7 are not diesel, because the total has to be 9. And if there are 10 silver cars, 4 of them being diesel, that means that 6 of them are not diesel. Now, to the actual question, 1 car from the garage is selected at random. What's the probability that it's a red car or a diesel car? So which ones fulfill that criteria? So we want red. Here's red. Or diesel. So there's diesel. Now you'll notice that the red diesel has come in to this twice, because it counts as a red car and then it also counts as a diesel car. If you do a table like this, it makes things, I think, a little bit easier, because you can just say, well, the total amount of options is 3 plus 2 plus 4 plus 7, all the numbers that are highlighted. If you do it purely mathematically, if you just try and do out the fractions, you're going to end up counting these red diesel cars twice, because they appear in your diesel list and they also appear in your red list. And so what you're going to have to do is take away 2 out of the 24 cars at the end of it, because you've counted them twice. But as I say, with this table, we don't need to worry about that. We can just say probability of picking red or diesel is just the total number here. So 3 plus 2 is 5, plus 4 makes 9, plus 7 makes 16, out of the total of 24, which we can then simplify down to 2 out of 3. So that's the whole question done. Thank you very much for watching, and hopefully I'll see you again in question 2.